actual chemical reaction, okay? And this is, again, another one of these kind of big word problems that I like to do. So I'm going to show you how I break down this problem, how we turn the problem into a reaction, and how we go about doing this, okay? So let's read it. So nitrogen gas, okay, so first I'm going to underscore that, and I'm going to remind myself nitrogen gas is N2, right? Can be prepared. So can be prepared means nitrogen gas is going to be a product, okay? Nitrogen gas can be prepared. Automatically that tells me I am making nitrogen gas. Bypassing gaseous ammonia over solid copper 2 oxide at high temperature. The other products of the reaction are solid copper and water vapor. Okay? So that tells me my other products, right, are solid copper. So I'll write a Cu solid. We know that this is nitrogen gas, so I got to put that G down there for gas. Let me go ahead and make this just a little bit more clear. Okay. And they also tell us the other products of solid copper and water vapor. So I know water vapor is H2O gas. Okay, there's my products. What about my reactants? Well, it said gaseous ammonia, NH3. Okay, great. And solid copper 2 oxide. Okay, copper 2 oxide is CuO. Because remember, each oxygen's minus 2, and if the copper, that copper 2, remember, tells me that that's a positive 2 copper, okay? So I need 1 copper for every oxygen. And then now, of course, I have to balance this equation because I can see that I've got 2 nitrogens here, but only 1 nitrogen there. So I'm going to put a 2 in front of there to start, all right? And let's see, when I do that, that gives me 2 times 3. That gives me 6 hydrogens. Okay. And here I only got 2, so I'm going to put a 3 over here. And now my hydrogens are balanced, so that's good. But now I've added 3 more oxygens, but I only have 1 oxygen on this side. So now I'm going to add 3 to this side. And then finally, I see now I've added 3 coppers, so now I need 3 coppers over here, and this is finally balanced. Okay, let's double check. 2 nitrogens, 1, 2, and then 2 nitrogens, and then 2 times 3 gives me 6 hydrogens, and 3 times 2 gives me 6 hydrogens, and then 3 oxygens, 3 oxygens, 3 coppers, we're good to go. Okay, so now what is this problem even asking me? It says if a sample containing 18.1 grams of ammonia, NH3, and I'm going to write 18.1 grams right there under the ammonia, is reacted with 90.4 grams of copper 2 oxide. What is the limiting reagent? Okay. And how many grams of N2 will be formed? So I'm going to put a question mark right there for how many grams. And I'm just going to back up really quick. I think I realized I forgot to say, because in a simple example we were doing, the ham is my limiting reagent. Because, so I'm sorry, I forgot to say that in the previous slide. The ham is limiting because you notice from the cheese I could make 12 sandwiches, from the buns I could make 6 sandwiches, but from the ham I could only make 5 sandwiches, so I would run out of ham first. That's what makes this the limiting reagent, okay? So now in this chemical reaction, okay, and granted, you know, I gave you a pretty hard problem to work through, but let's just focus on that. Now we have a reaction, okay? We have 18.1 grams of ammonia and 90.4 grams of copper 2 oxide. Which one is limiting, okay? The ammonia or the copper? And once we know which one is limiting, how much nitrogen can we even make? Okay, so what we're going to do, we're going to do 2 calculations. We're first going to start with this 18.1 grams of ammonia and come all the way over to nitrogen. And we'll see how many grams of N2 can be formed by 18.1 grams of NH3. Okay, so I'll call that number 1. Then we're going to do a second calculation that I'll call number 2, where we're going to see how many grams of nitrogen can be made from 90.4 grams of copper 2 oxide. And the least is the most amount of nitrogen we can make. And whichever one turns out to be the least, whichever one makes the least amount of nitrogen, was the limiting reagent. Okay, so let's start on this calculation number 1. And like always, I'm going to start with the number that I have, which is 18.1 grams of NH3. Okay, and so what I need to do, I need to convert 18.1 grams of NH3 into moles of NH3, and then I can convert moles of NH3 into moles of N2 from this 2-to-1 ratio. And then finally, I can convert moles of N2 into grams of N2. Okay, so here I need to cancel my grams of NH3 and make it moles of NH3. And I do that with the molar mass. Okay, and so if you look up the mass of nitrogen and hydrogen and do all that, you should get 17.02 grams of NH3 in 1 mole. Great, so I can cancel those. And now I need to convert moles of NH3 into moles of N2, just like I did back here, right? Where I said, I know that in my perfect ratio, 3 slices of ham makes 1 ham and cheese sandwich. So that's my conversion factor from one reagent to another reagent, or from one reagent to, in this case, a product. Okay. So my reaction, let's write these a little bit more clear. That says mole, mole. Okay. Mole. Okay, so I know from this balanced reaction, I have 2 moles of NH3, right, for every 1 mole of N2. Remember, there's no coefficient there, so we just assume that it's 1, okay? And then now finally, look, I reminded myself that I needed to get to grams of nitrogen, so finally I can say moles of nitrogen to grams of nitrogen. And I know from the periodic table, in 1 mole of nitrogen, there's 28.00 grams of nitrogen, because each nitrogen atom is 14 grams per mole. So 2 of them makes 28. Okay. And now let's see how we did on the canceling. Mole of NH3 cancels with mole of NH3. And look, I'm not canceling the number. I'm just canceling the unit. Okay. And then mole of N2 cancels with mole of N2. And then what I'm left with in this answer will be some grams of N2. Okay, so let's do the numbers. So I'm going to say 18.1 times 1 times 1 times 28. So I could probably just make that 18.1 times 28, 0.00, sure, equals 506.8 something, something, something. And then I've got to divide it by 17.02. So we'll say divide by 17.02 equals, and then I've got to divide it by 2. Divide by 2. And I can still say, divide by 1 again, but we know what the result of that will be. So 14.888, and you can see I've got from the 18.1, 3 sig figs, so this should be 14.9. Okay. So 14 grams of nitrogen can be made from 18.1 grams of ammonia, assuming that I had a large excess of copper 2 oxide. And what that means is, by assuming I had a large excess of copper 2 oxide, that in this calculation, copper didn't even enter the equation, right? So we're just assuming copper is in excess, like we have as much copper 2 oxide as we need. Now we're going to have to flip the script on that and calculate it the other way. We're going to calculate it starting with the 90.4 grams of copper 2 oxide, assuming the NH3 is in excess, and we'll see how much nitrogen we make from there. So I can follow this same kind of pattern where I know I'm going to have to convert grams of copper 2 oxide into moles of copper 2 oxide. And we know from the periodic table that there's 79.55 grams per copper oxide per mole. So prove this to yourself. Prove that you can get that molar mass, okay? And then I know the grams and the grams are going to cancel. And then now following the same pattern that I did, I know I want to convert moles of copper 2 oxide into moles of nitrogen. And my balanced recipe says 3 moles of copper 2 oxide are needed to make 1 mole of nitrogen gas. And then finally I can copy the line identically by saying I know 1 mole of nitrogen is 28.00 grams of nitrogen, and then all of my units are going to cancel, and then similarly I'm left with grams of N2. That's going to be the unit of my final answer. So let's do the calculation. I'm going to do 90.4 times 28. Okay. Equals. And now I'm going to say divided by 79.55 equals. And now I'm going to say divided by 3 equals. Okay, 10.6 grams. 10.6 with 3 sig figs. Okay, so now let's compare those two. All right. If I started with 18.1 grams of ammonia, and I wasn't concerned with how much copper 2 oxide I had. I was only thinking about what I could make with my 18.1 grams of ammonia. I can make 14.9 grams of nitrogen with that amount. But now if I ignore the ammonia and I look at the copper 2 oxide instead, 90.4 grams of copper 2 oxide will only make 10.6 grams of nitrogen. And remember, the least is the most. So so how many grams of N2 can be formed? That many. And which is the limiting reagent? Copper 2 oxide is limiting. And so what does that mean to be limiting? Well, it means you're going to run out first, okay? It means that we're going to use up all of the copper 2 oxide. And when we think about a chemical reaction, we can't just think of like one reactant at a time, right? Both reactants are reacting. So when I take this 90.4 grams of copper 2 oxide and 18.1 grams of ammonia, the copper 2 oxide is going to run out first. And thereby I'm going to have excess NH3. So this will be my, let me put this in a different color so we can later on go back and look. Sure, that gold color looks nice. Oh, what do you want to bet it's not going to show up very well? Actually, not bad. Excess and then limiting, okay? And then, oh yeah, I gotta move the talking head out of the way to switch back colors. Okay. Here you go. All right, so we could even go as far as to calculate how much excess ammonia we would have, okay? And we are going to do that next.